Glad to be here, and thanks, Susan, for inviting me to come. I'm very excited about today, and I want to first congratulate and thank the speakers that came before me. They did an amazing job, and if you could, please give them a round of applause. Science is a very tricky one, as you're going to find out today. And it gets even more tricky as we get into understanding more about it. So there's going to be some slides we'll just zip right by because they've been very eloquently covered by the preceding speakers. And so we've got a lot to cover, and I get a little excited as I get going. And sometimes I'll speak about 460 words a minute, with Gus up to 780. So if I get going too fast, just raise your hand and I'll grab it back. How many here have or have been diagnosed with Lyme's? How many here have someone in their family that has been diagnosed with Lyme's? Okay. How many here are at the wrong meeting? Just checking, making sure. All right, guys, well, we're going to jump into this. I'm going to give you just a little bit of background on me. I came into essential oils kicking and screaming. I spent 7 years in the medical field to become a doctor, and then my wife helping me get through medical school was babysitting kids because she had our third child, and she was babysitting kids to help with this process. And I came home one day, and the one little boy, I looked at him and I said, "Honey, I don't want him back tomorrow. He's sick. He needs to go see the doctor." And so I went to school, came back the next day, and sure enough, there the little boy was. And I said, "Honey, what are you doing? This child is sick. This child looks like it's going to die. You can't have this child come back again." She says, "I had no choice. The father's in the hospital up on the hill, and the mother was life flighted to Salt Lake. They had no one to watch the child, so I took it." So we bundled up the little child and took it to the doctor, and it was diagnosed with hepatitis. And so my wife, through that process, had contracted hepatitis A. When I got her into the doctor, he told me she had probably about 4 hours to live. Her liver was almost completely destroyed. And he said, if we get her through the night, we would probably save her. And so I went home to take care of our kids. She was at the hospital. They had her on IV drip and everything. And 2 o'clock in the morning, I received a phone call, "Mr. Young, come quick." So I went zipping up there as fast as I could. And what happened is, this will kind of date me, I apologize, but you remember the clipboards where all the patient's records are? The clipboard was over the top of where she had drug interactions. And they had given her an IV drug of a medication she was highly allergic to, and it shut her body down. And she almost died from that. So the next morning I picked her up in my arms and I packed her out of the hospital. Dr. Stone stopped me and said, "You take her out, she'll die. As I leave her here, you'll kill her." So I left. He said, "You'll be back, you won't be able to deal with her. She is completely disabled, 100%. And you'll be back." After 3 days, I thought, man, you're right. This was difficult. So I was just finishing up my master's degree at the time, and I had to quit to take care of her. It took me 4 years to get her back normal. But that transitioned me from the medical world into the alternative health world. And from that point forth, I got really excited. So then I was introduced to essential oils. Still had that medical mindset. You know, they take this wonderful mind and they channel it into a very narrow form of thinking. Not that doctors are bad. It's just that the process by which we are trained or they are trained is the problem. that nothing exists outside of what they teach you. A boy with cancer, if you ask a question, well, doctor, how did it happen? Well, we don't know. Could it be diet? No. Well, if you don't know what caused it, then why are you ruling out diet? That's what frustrates me. Do you know that most trainings for medical doctors get less than a half hour in nutrition in their entire medical training? And it is the most important thing, as you just heard. So I came into it kicking and screaming, and once I got into it and I used those oils for the first time, I had my bursitis, my arm quit working because I was building a fence and I pounded 2,500 steel posts into the ground. And my shoulder said, stupid, why don't you get your son to do it? And so you go to the doctor and they give you a little shot with a little tiny needle, about that long, right in the joint of cortisone. And what does that do to your body? Destroys your immune system and degenerates your bone. But it takes care of the pain. Oh, miracles be. Well, I wouldn't do that because I knew what cortisone would do after being through medical school. So I was suffering the pain, my arm was frozen. And then oils were put on for the first time, and I'm doing this, and I'm going, okay, how to do it? Tell me the science behind it. And no one can tell me the science. So it launched me on a journey over coming in 30 years now on studying the chemical components and actions of essential oils in your body. Not the etheric, well, the moon and the stars lined up on the fall solstice and you use peppermint, and wham, you are healed. The science of what happens. So that's what we're going to go through today, a little bit of the science. So let me just share with you some of the background that we haven't heard. This is why we call it Beryllium Burnorfi, is because of this gentleman right here. He is the man who actually found the spirochete and identified it and said, this guy is a bad dude. And so from there, that name actually has stuck. Where does it come from? The spirochete has a very device group of bacteria. It is found in deep marine sediment. Is that ring a bell anywhere around here? What was here before the Great Lakes? Even more water.
Glaciers.
Deep marine sediment. So the spirochete bacteria is in the soil all around here. And so you'll also find it in what? Termites? What eats termites? Mice, other kind of mammals. And so this Beryllium burnorfi is the causal agent. The Lyme is coming from the soil into the mammals and into the other species. There is a very similar bacteria that is responsible for the very contagious syphilis. Very, very similar action, very hard to deal with. It is widespread in nature. It's involved in different mammals. So you're going to have it in mice, raccoons, possums, deer. It's transmitted by blood-sucking and feeding insects like mosquitoes. They claim it doesn't. And you just heard today that they say it's not transmitted through any kind of human contact, but it is. We know that, and you'll learn why and how that is transmitted. There's a lot of what I call regurgitated misinformation in a lot of different areas, and in Lyme's is one of the main areas where you'll find this. Here's what's so crazy about Lyme's, guys. You'll find this interesting. It has 132 gene encoding lipoproteins. 132. Most bacteria have about 7 or 8. It has 132 lipoproteins. Now these are the building blocks of that DNA aspect to this bacterium. That's why it is a stealth pathogen. That is why it was different in each of your bodies when it is enacted with antibiotics. We're going to talk about more of that in a little bit. This is the reason why it's so hard to control them. Well, the abundance of the lipoprotein in Borrelia burgdorferi is the framework of its function, and it will morph and change to survive. In fact, they actually found spirochete, Borrelia burgdorferi, in fossilized shells in the Great Lakes. So it's been here a long time. So if it's been here a long time, then why do we see it encroaching into the human life? Like we saw, someone showed, who showed the pictures? Okay, of how it's increased over the years. But that's not the whole story. Here's kind of the rest of that story. It's on the move, and I'll show you where it's on the move to, okay? So this is our little culprit that we want to look at real quick, the black-legged tick. This is the guy that does most of the damage up in this area and responsible for the disease spread here in this region as well as other region. And he's just doing what he's supposed to do, and that's to feed and procreate. Northwest is recorded the highest, and it's on the move. This little guy is going into California and Florida and Texas and Louisiana. How is it getting down there? People are coming to your wonderful state and other states that have infestation of this with your pets now. And it's getting on the pets and taking it back to their local area, dropping off, and now it's on the move. And we're seeing massive amounts of lines showing up in these other states. This tick has not only been able to adapt to a warm region, but so has Borrelia. It's been able to adapt. So if you look at what the projections are by 2050, that's what they're projecting will happen with Borrelia. It'll be in that large of areas. Not all reports are being made of people that have been infected with Lyme's. And so there are a lot more out there that are silently suffering with it and have no idea or have been misdiagnosed. And that's the challenge. So what is Lyme's? We know a little bit more about it. Here's a really close-up graphic of Borrelia. It is a spirochete, and it is kind of interesting. We'll show a video here in a little bit how it works. Now, one of the things that we have to realize is you need to have that tick attached to you at least 48 hours if you're going to get it from a tick. 36 to 48 hours for it to be transmitted. The worst thing you can do if you find a tick attached to you, and we'll talk about it a little later, but is grab it and squeeze it real hard. Because you're going to shoot the Borrelia right from him into you. Okay, so don't go squeezing on him. It's kind of something that you need to look at. Okay, early warning signs. This is not always it, but this is one of the typical ones. Is the bullseye that you'll see, the swollen lymph nodes, flu-like symptoms. It can happen. Usually, the flu-like symptoms are going to be first. In fact, we heard you've had flu twice in a row, just bam, bam. And you'll see why those symptoms are part of this unseen symptoms. We go, oh, I just have flu. I just have a cold, or maybe I ate a bad hot dog. But it has a lot more to do with that than you think. So how is it treated? Typically, this is how it's treated, is with antibiotics for the infection, because it's a bacteria. And antibiotics are to kill bacteria. But does it kill bacteria? Never in the history of antibiotics, not once in the history of antibiotics, have they ever killed a bacteria. Never once. All they have done is morph the bacteria. What do we mean by morphing? Changing, shifting, stealth. That's what's going on. So let's take a look at some of the interesting facts. Here's your red blood cells. Here's a white blood cell, and there's the Borrelia, the spirochete, moving through the blood, seeking a host. Now here's what's amazing, guys. The Borrelia feeds, amazingly, on red blood cells. it also feeds on white blood cells. What's the difference? Go ahead. Oxygen and nutrients. White blood cells? Fight infection. Why would they feed on white blood cells? So they can be fought. You're right. That's the first little tidbit there, but there's another tidbit. How long do red blood cells last in your body before they're decommissioned and recycled? About 30 days. White blood cells? 48 plus. So they live longer. So they're able to hijack your DNA if there's a white blood cell. Okay? So let's look at this invasive structure. Not only can the Borrelia spirochete cloak itself when it enters your body, see it actually has a coating on the outer structure, the inner structure, that coats it to stop it from being recognized by your immune system. And then it has this little flagellum tail that helps it to move through your body. And so with this here little flagellum tail, your body will actually create a protein that's called your antigens or your antibodies, and it does that because the proteins, well, because it has 132 different proteins, it'll keep changing its proteins. So when your immune system sets down an antigen to go after to kill it, it's already changed its protein structure, and the antigen goes out there and says, what the heck are you talking about? There's nothing here. Because it changed its protein structure to hide from your body killing it. It's a shapeshifter. It will shift its shape, and it will change, and it will move, and it will twist, and it will turn, and it becomes something that you've never seen before, or the doctors have never seen before. And so what happens here is because of the shifting of the proteins and the antibiotics then that are used, and well, I think I have some slides here. I won't jump into it till we get to that. All right, so let's just kind of look at how these little guys do their job here. This is a good little video. I think you'll like it. Because you'll see right here, can't get high enough. The top up there is going to be a white blood cell, and watch what happens. The white blood cell is coming to attack it, and it's saying, oh, thank you, and there it goes right inside. Oh, it's dead. No. It's hijacking your DNA. It's morphing, because once it hijacks your DNA, guess what? There's no way your immune system will ever find it, because now it's part of you. This is the stealth pathogen that is so scary, and there's several bacteria out there that are like that, okay? Okay, here's another video watching the movement of Borrelia. Okay, that's a Borrelia cluster. Should be some video or some sound to this, but maybe it's not going to work. It's not working.
The same
there it is.
culture, cluster, and higher power, showing the intertwined spirochetes. A single spirochete showing the flagellar tail. This is in transitional movement in a fluid medium. This spirochete is traveling both forwards and backwards. This is accomplished by changing the direction of its rotation.
Okay, changing the direction of its rotation. How does it do that? By changing the electrical poles. Changes the rotation. Who's an electrician here? Can you wire a motor to run backwards? You can. By changing the poles, and it'll run in the opposite direction, counterclockwise or clockwise. So it changes the electric pulse. So if it has electrical energy, then it has to have a frequency. We're going to talk about that too, guys. Very, very powerful.
Here, spirochete subdividing into two, still held together by flagellar material between the two spirochetes. This is the last two separated in the subdivision process. Here, a variety of spirochetes showing different types of movement, flexing, bending, twisting. The transitional movement is always a rigid spiraling type of action. Here in phase contrast, two spirochetes showing the transitional type movement. This spirochete is showing a non-transitional type of movement, which is a flexing, coiling, uncoiling, and seems to be a type of relaxation the spirochete does during its transitional movement. It's also used if it gets stuck and is trying to break free. Here you see two different waveforms in the spirochete. Dark field, a single spirochete. This is a different type of transitional movement in the spirochete.
Almost freak you out watching it. Here's another presentation, just real quick. We'll zip through this one. Come on, let's go here. Maybe. Not the same one. Trying to get this to go by. Sometimes it freezes up on me. Come on. Be nice to me. Technology is great, huh? If you can figure out how to use it. All right. So I want to just share with you now that you've seen the spirochete and know that it has 132 proteins that it can change, shift, and more. Let's look at what is really causing a lot of problems. Doctors warn that a garden variety type of bacteria, which is normally present in the human intestinal tract, may be morphing into a tough to treat superbug. February 26, 2014. Second patient in New Mexico, man, 48, who has displayed dialysis because the kidneys having problems because of strep B, discovered that it's resistant to vancomycin. Bacteria is multi-drug resistance, September 12, 2018. So we know that there's all kinds of drug-resistant or bacteria-resistant, antibiotic-resistant bacteria out there. Have you heard of CRE? Yeah. CRE is a new strain, different than your MRSA, that now will actually, what's happening is the antibiotics are morphing the bacterias, and I'll explain how that's happening, but now 2 or 3 bacterias are joining their DNA, and you're getting a super morphed bacteria that is not a single Borrelia or a single strep or a single E. coli. It is a Borrelia, strep, E. coli, Pseudomonas bacteria. You contract CRE, you die in about 3 days. C. And so that's what's going on with these here drug-resistant bacteriums out there. So mainstream medicine believes that all illnesses are caused by germs, genetic weaknesses, deformities, trauma. There's over 10,000 different diseases, and each disease requires an outside intervention for them to be taken care of. What's their outside intervention? Drugs, antibiotics, or surgery. See, doctors are not bad. Doctors are trained. Guys, I was trained to diagnose and to treat, not to prevent. That's the difference. Like was said earlier, if you have a broken leg and it's bone sticking out, go to the doctor. They're trained in trauma and they're trained in diagnosing. But it's the drug companies that train them on drugs. So most illnesses are due to what? Cellular malfunction. If a spirochete is inside of your cell, is it going to function correctly? Chances are not. Caused by toxic cellular buildup, or what is called toxic body burden. Eating the wrong foods. Do you realize that if you live in a community where there is bad quality of air, like Detroit, Chicago, or some of the larger cities, that is living there for 8 hours a day is equivalent of smoking 300 cigarettes? That's how much toxins you'll get out of the air. Do you know how many toxins are within our food supply, our water supply? Toxic body burden, which changes the cell structure. Cellular malnutrition. You heard some great information today about nutrition and eating for your body type. One of the things that feeds Borrelia is sugar. Mm-hmm. Let me rephrase that. One of the things that feeds Borrelia is glucose. Can you get glucose from non-sugar products? Here's an experiment for you. Who likes French fries? All right. Buddy, here you go. This is your homework assignment, okay? Have mom and dad buy you some fries on the way home, okay? You just take a fry without fry sauce or ketchup on it and just put it in your mouth and just chew on it, don't swallow. You chew on it and chew on it and chew on it for just about 2 minutes. And then ask yourself, is this sweet? The starches in the potato turn to glucose. So guys, it doesn't have to be that you're putting table sugar on. Your carbohydrates, your quick carbohydrates go right to sugar. And they create this toxic body burden. So L-form formation and survival. Guys, now we've laid the foundation. Now let's get into the big stuff, the stuff that I'm very passionate about. In 2008, I was sitting at my TV, or sitting at my desk, and the TV was going in the background, and I heard the newscaster, Mike Morris, came on, and he said, "Today, scientists have uncovered a rare bacteria in Hanford, Washington, that they can't identify, and they are afraid that it'll wipe out the entire human population." Yeah, that's what I did. What? I about got the neck jerk. Whoa, what's going on? And that was all he said. So I waited for the next day for a newscast. Nothing about it. Waited the next day. Nothing about it. Called the news station. What's going on with this rare bacteria in Hanford, Washington? What's going on? What's happening? Couldn't get any information. So I went to Hanford, Washington. I had no idea that Hanford, Washington was the disposal place for the nuclear leftover waste from making the atom bomb during the Second World War. 177 1-million-gallon containers buried in the soil in Hanford, Washington. They went down the Columbia River to the ocean, was testing the ocean, and found a radioactive isotope in the water. So they started coming up until they couldn't find it, and they went back down and found it and said, well, what's here? Hanford, Washington. So they went in and core drilled underneath these here tanks to see if they were leaking. And yes, they were leaking. After all those years buried in the ground, this boiling radioactive isotope has rusted through the containers, dripping into the soil, one drop at a time, and finally made its way to the Columbia River and cleared the ocean. And so that's where this report came from. Well, when they core drilled, they started testing the bacteria, and that's where they found this rare bacteria that's going to wipe out the human population. And they literally showed pictures on that newscast of scientists in their complete radioactive gear and protective stuff, carrying little vials into the lab. Nothing came out of that. 75 days later, there was a little blurb in the newspaper, because I kept calling and asking, what the heck? To get in here, you have to have security clearance. Finally, they sent out a little thing in the newspaper in Salt Lake City. Rare bacteria discovered to be normal bacteria found in the soil. I went, okay, what's the countdown? So that started my journey into cell wall deficient form or cell wall deviant form bacterium stealth pathogens. And that was my journey that really blew me away. You see, what happened is when they opened up the soil and put the tank in there, the bacteria that's in the soil, like Listeria or Borrelia or any other bacteria, is living in the host. The host is the soil. And if you change the host, the bacteria has to morph to survive. And if it doesn't morph, it can die. Okay? And so here they put this radioactive boiling isotope into the host. You just ate a Big Mac with all the preservatives. You just put some stuff in the host, you. Now, the bacteria in your gut have to change to survive that situation. Well, over time and distance, the bacteria morphed and changed into what they couldn't figure out what it was. Because when you stain a bacteria, it's a gram-positive or gram-negative. What stains? The lipoprotein, the cell membrane. Remember that. This is so crucial. The cell membrane is what stains. If it stains, it's a positive. If it doesn't stain, it's a negative. Okay? So they tested it, and it wouldn't stain. They couldn't figure out what it was. After 72 days of culturing this, it reclassified to its classical form, and it stained, and they knew exactly what it was. So it had morphed. It had shape-shifted from a classical bacteria to an L form, back to a classical bacteria. This is the shape-shifting that goes on with the bacteria. This blew me away. When I actually discovered that, then I started delving into it. Guys, do you know how long we've known about this? Over 100 years. Let's go with the history. This is kind of fun. Researchers have known about this for centuries, not just 100 years. But here's what's amazing about this. It's been around long enough that we understand that these diseases, whoops, push the wrong button again. These diseases here are ones that will morph. And today we know of 50 different bacterias that are capable of morphing into L form. L form stands for little body or large body, or the actual institute that discovered L forms in the 18th century, Lister Laboratory, where you actually used to get your Listerine. You know, Listerine back then had thyme oil in it. Yeah, thyme essential oil in Listerine. That's what made it burn so much. It killed everything that was bad. But guess what today? They don't use thyme oil. They use synthetic thymol that your body does not recognize. So over the past century, researchers identified over 50 species of bacteria capable of transforming into L forms, and there will be more to come. Major research and doctors are not aware of L forms. In fact, it's fun. I love going in to see a doctor all the time. I say, have you ever heard of L forms? What's that? Cell wall deficient form bacteria? I said, have you heard of antibiotic resistant bacteria? Oh, yeah. That's an L form. Oh, really? Yeah, I love talking to them. It's awesome. Okay. So let's look at an L form. Here is your typical L form. Your bacteria, when it first discovered in 1930, it morphed into classical, from a variant from a classical. So here is your classical, how they just split and divide. And then what happens is you get treated with antibiotic, and the antibiotic attacks the prostaglandin layer, or the lipoprotein layer of the cell membrane. What's the cell membrane for on a bacteria? To what? To protect it, yes, kind of, and to hold it in a shape. Because we have round bacteria, we have rod bacteria, we have spirochete bacteria, is to hold it in its shape. And so if we use an antibiotic to attack the prostaglandin layer, it takes the cell membrane off. Well, what's left? See, this is why they said, oh, we just killed it because we just killed the cell membrane, so now it's dead. What's inside the cell?
Cell wall.
Cell wall, that's, and even further than that, energy, even more,
Cytoplasm, the DNA.
nucleus, DNA, and RNA, what's called in the scientific world nucleic acid. So when they kill the cell membrane, what's left is the nucleic acid, the DNA, and it's in tiny, tiny, tiny micro particles that now can float around your bloodstream. Now this is going to shake you up a bit. Guys, they have found L-form bacteria inside of sperm. So when you stop and think about that, can you contract Lyme's from sexual activity? Absolutely. If it's been treated by antibiotics and it's in the L-form stage, they have found it in a parasite's gut inside of a child's stomach. It's that small. That's what L-form is, because it no longer stays with its shape. It goes into a weird morphing shape that will have clusters of nucleic acid. That's why CRE is so dangerous right now, because when you're treated with antibiotics and you have multiple bacteria in your body that it goes after and takes off the prostaglandin layer, now you have DNA from E. coli, Lyme's, Pseudomonas, all floating around and coming together and creating one mutated super DNA bacteria. That's why it's so deadly. So are antibiotics bad? Oh, you're right on. Then they do a biofilm. We're going to talk about that next. You're right on target. Because once they become a biofilm, they're 1,000 times harder to kill. That's why when you are treated with antibiotics with Lyme's disease, guess what? You feel better. A lot of people start feeling, oh, I've got it done. I've got it handled. And all of a sudden, stress comes in your life, and boom, it flares, and guess what? He's back. It was never gone. The antibiotics just kept it morphed, and in the L-form stage, as soon as it has a chance to find a place, guys, let's do this. I'm going to use cancer for an example, but it relates here with lives. You go to the doctor, you have cancer, they go through all the treatments, and they say, oh good, you're in remission. We're so happy for you. You're good to 2 to 5 years. How do they know 2 to 5 years? Well, what's the deal? Is it just because that's what happens? Well, it is. Because it takes 2 to 5 years for that bacteria that had morphed, that caused the cancer agent to happen because it hijacked your cells and caused it to replicate out of control, to reclassify, and now the cancer's back. But is it back at the same location? No. Let me give you a path, just for example. Breast cancer. When it comes back, lungs, brain. Prostate cancer, bone, brain. Colon cancer, liver, brain. Because they're in an L-form stage, they're so small that they can get inside of a sperm, which is smaller than a red blood cell. The L-form will go wherever it wants in your body. So you're saying, well, gee, I heard here. What's it doing? It's shifting and moving to other locations in your body because it's in the L-form stage. Now, will just antibiotics cause L-forms? It's not a trick question. No.
No, it's not just antibiotics.
please breathe, because we'll get to some good stuff, the solution, okay? Please breathe. I'm seeing you holding your breath. I don't want to create trauma on you, but guys, you need, if you've not, why are they not teaching this? Why are they not teaching this? I have been teaching this since 2008. Yeah, that's funny, okay.
Yeah.
How do antibodies kill the bacteria? Well, we talked about that, so we'll go by how it attacks the prostaglandin, what's left over is the DNA, so we'll go past that. All right, here's a couple examples. Here's your different your antibiotics and how they work, penicillin and chloroquine. These are the two main ones they'll work with Lyme's. And all they do is look at this. This here bacteria, what does it do? It causes the bacteria to take on water until it explodes. Now the DNA is floating all over the place.
Oh my God.
Okay? The other just takes the bacterial wall off. Just different in a way that different. Erythromycin, how many have been prescribed erythromycin?
Mm-hmm.
Yeah. And guess what it does? It then instantly attacks the Borrelia cell wall. Instantly. Turning it into an L form. And now that little dude is stealth. And they can't find it. Oh, they'll do a blood test on you and they can't. Oh, we got it. Then why do I feel like crap? Because they didn't get it. They just morphed it. Just more information here about the way the DNA strands